Hello, everybody. My name is Luke Benoit, and today I'm very excited to share with you this new technology using Gaze-Contingent Contextual AI for smart eyewear and how it's really revolutionizing and defining the augmented and virtual reality industry. So just to give you an overview of where the AR VR industry is actually at. The purpose before was creating these novel architectures to augment the real world. So using things like advanced displays, advanced lenses, to truly create this digital world and interface it with the real world. However, what's really transformed this industry and improved adoption is actually the purpose of augmenting human capability. And so this is being done through what's called AI-assisted AR glasses. And so these devices use multiple sensors to detect where the user is looking, where the user is at, and then providing the interface for AI to help improve human capability with these smart glasses. And so the Meta Ray-Ban has really opened up this industry, and others among Amazon and Snapchat have really started to implement this technology for future consumer devices. And so to do contextual based AI, so first of all, contextual AI uses multimodal input. So we use things like text, speech, images, videos to understand the user's intent and to enhance the human capabilities. And it's driven by what's called multimodal large language models. So one of the big ones, especially for this contextual based AI uh, application, are what's called Flamingo. And so Flamingo is a supervised learning model that's trained on image text pairs, and it uses autoregressive prediction and contrastive vision language alignment to help take speech, for example, so what the user is saying or what is the input text, to also encode an image and then find what is the relation between those, and then using regressive prediction provide the correct response. But the core problem, especially with smart accessories, is that they don't understand the user's spatial pattern, and that degrades the understanding of the user's intent or where the user is actually looking within the environment. So in comes Gaze-Contingent AI. And so one of the biggest examples and one of the most innovative is called Gaze GPT. And so it bridges the ability to augment human capability and actual human capability while also opening up AI applications. So it takes these models such as Flamingo and continuously updates from the with the inside and outside world. So the inside world would be where the user's gaze position is at, and then the outside world is where that relates to where the user is looking. And then we create a user image that can be used for models like Flamingo. And actually, this type of technology uses a digital twin to capture what's called the glints, the reflections off the eye, to predict the eye movement, the gaze vector, and that helps improve the latency and accuracy of the system. And so you can see here how we take an image from a detector and then mapping the foveated region, which is where the highest visual acuity and where our eye typically focuses at. It's also called the visual axis. This position is where we're actually looking. And so instead of identifying a coffee cup and saying, this is a coffee cup that you're looking at, it actually helps the accuracy by identifying the car. And so there's a lot of amazing possibilities with this technology. And I'll show two of these here for you just to show how, what it can do. So here's an
As soon as you do
example.
that, you move away from the
Go
context of
to,
data collection.
Help
so
me pick up some red onions, taking you to red onions.
so this is a blind patient, and you can see that they are able to take the user
Are here.
to red onions and allow them to pick up the red onions. So that's one of Meta's projects there. Google also has a project called Project Astro, and they've really expanded upon this and are going to release a product soon with this technology.
What can I add here to make this system faster? Adding a cache between the server and database could improve speed.
And you can see how it's able to accurately see where the user is looking, what object the user is referring to, and then make a thoughtful and accurate response using these multimodal models. So this is a very promising technology. Of course, though, there are ethical concerns, particularly, with the outside world, having always on cameras that capture the environment, and then having bystander consent is always going to be an issue, especially with these devices that capture the real world continuously. And then the bias and safety and output, so the incorrect or hallucinating responses could cause harm. So example, if you have a food allergy and it identifies the food incorrectly, that can cause a significant issue. So as accuracy improves, these issues can be, thoroughly reduced to allow for these technologies to be widely adoptable and safe for users. Thank you.